Okay, for number 23, again, just, we went through it already with technique that probably most teachers are teaching. But what I do want to point out that there are other ways of doing it, and you want to find a way that you're comfortable. Now, sometimes one way is going to work better than the other. I can't guarantee what's going to work best for you, but if you try a variety of methods, you'll certainly arrive upon one that you do favor, all right? So this one over here, again, R is equal to secant theta, tan theta. So one thing you could think about is just, how are these things related to the Cartesian system? So let me go through that with you. So the related to Cartesian system is x being equal to r times the cosine of theta. And what's r? Well, I'm looking at it, and this is what r is. It's actually a function of theta. So I'll write that down. So it's going to be, it's actually secant theta times tangent theta. That's what r is, and then times the cosine of theta. Well, what's nice about this is that the secant theta times the cosine theta is conditionally 1. So I'll write this over here. X is actually just equal to tangent of theta. Let's write y down. What's y going to be? Y will be equal to r sine theta. Again, just what we did before, what's r? It's a function of theta, and I know what it is. It's secant theta, tan theta. That's what the r is, and multiply it by sine. Now, certainly I want to simplify this because it looks so strange to me. And I'll write it as secant is 1 over cosine of theta. The tangent is sine theta over cosine theta. And sine theta is just simply sine theta. I'll put it over 1 now. What's it going to be? Well, looking at it, it looks like it's tangent squared. All right, relatively simple. So again, I want to point out to you that looking at something a little bit differently can't hurt. And I got two things happening at this point, and I'm going to highlight those things for you. So I know x is really just this, and y is just that. All right, and to get my eraser out, I start to erase other things in the problem that I really don't need anymore. This is me just be speaking through a different technique to do the problem. All right, what's the question? What's dy dx? All right, so what I'm going to do is write down dx d theta. So dx d theta is equal to the secant squared theta. That wasn't so bad. Now, what's dy d theta? A little more complicated. It's going to be 2 times the tangent to the first power of theta, of course. I put these in parentheses. Times the root of tangent, which is secant squared. All right, what do I want? I want dy dx. And what's that going to equal? Well, that's going to equal dy d theta over dx d theta. What's dy d theta? Well, I just did it. It's actually 2 tan theta secant squared theta. What's dx d theta? It's secant squared. Again, there's a conditional cancellation. And what do I get? Well, I get dy dx, quite simply, is 2 tangent of theta. Let me just outline that where's in the key, right over here. Let's just review again what we did initially. It's really what a lot of teachers do. They write down, basic generic formulas for derivatives. A little complicated. Like I wouldn't want to say I want to memorize that. Could derive it each time, though, if you can remember the derivation of it and apply it. Look how much work that was. But there's another way, and we just did the other way. And I noticed there's an error in my key at this point, and I have to correct that. That's 2 over here. I just noticed it. So dy dx is actually 2 tan theta. Let's say if we got that written down. Yeah, 2 tan theta. In both cases, no matter how I proceed, I will be getting 2 tan theta. And a correction in my key needs to be made. Thank you.